Here we have a breadboard. Two resistors connected in series combination. We haven't covered series circuit yet, but our aim for today is just to illustrate how to use a handheld multimeter in measuring resistance, voltage, and current. The first thing we will do is measure the resistance of this resistor as well as the resistance of the next one. Now, as a precaution, when you are measuring resistance, when your multimeter is set to the resistance function, make sure that the power is off. So, let's try to measure the resistance of our first resistor here. $999, around 1K. The nominal value of this resistor is 1K, and you can verify that using the color coding, which we will discuss later. The second one, 386 ohms. Now, measuring resistance, you don't need to worry about polarities. I mean, you will measure the same thing. Same with this one. I mean, you switch the probe, you will get the same thing. Resistor has no polarity. But if you remember in our simulation, when you're placing the resistor in our circuit, there's sort of positive and negative terminal. But that is for the purpose of SPICE simulation. But in actual circuits, resistors has no polarity. When you're measuring the resistance, it would not matter how you connect the probe. Now, what we will do is now we will measure the voltage drop across this resistor and across the second one. And to do that, let us set this into the voltage function. It's now on the DC mode. This handheld multimeter, you can also set it to AC mode, alternating current. And back to DC volts. If I just turn it off and switch it on again, it will default into DC volts. Now I set it to 10 volts and 50 milliampere or 0.05 ampere. The circuit will draw much less than this. So now if we enable the power supply, now it will start supplying power to the circuit. So in this case, the current, the conventional current will be flowing from this positive terminal of the power supply, going through the red wire, the red probe, going there, going through all this red interconnecting wire here, and to the top end of our series combination. Of course, current will flow through this resistor, to this connecting wire, our jumper, and through this resistor, through this black wire. This black wire will be connected to our black terminal here, which is connected to the negative terminal of the power supply. So it is a closed loop now. Current is flowing through the circuit in one direction. It is a DC circuit. And since the positive terminal is connected to this end, and the black terminal, which is the negative, is connected to this end, I can say that this end is more positive with respect to this one. This end is more positive with respect to this one. And this side of this resistor is more positive with respect to the other side, because current, conventional current, is flowing in that direction. Now let's measure the voltage across our first resistor. We are already set to DC voltage, and the proper way to do it is connect the red probe to the more positive side which is this side. So connect there. It's around 7.02 volts. Yes, 7.02 volts. The other one, 2.733 volts. So there are only two resistors in our circuit. If you add them together, it should roughly be equal to the power supply voltage, which is 10 volts. But of course, there will be some voltages drop across this wire, very small, across the interconnection, especially if it is not tight. There might be some voltages drop there, but it's not our goal to explain that kind of voltages drop at the moment. I mean, our goal is just how to measure the voltage drop across a resistor. So again, to measure the voltage drop here, 7.04. Now, you might say, what would have happened if I switch the probe? I mean, connect here and connect here. You will get the same numerical result, except that the sign is now negative. What it means is that you connect the red probe to the more negative side of the resistor. Same thing with this. If I do with that, you get minus 2.72 volts. So what it meant is this side is more negative with respect to this. That's why you're getting negative. But if you have an idea which one is more positive, the best way is put it in the right, I would say, red probe to the more positive one, black to the more negative one, and you will get the right sign. Now we will be showing how to use this handheld multimeter to measure the current flowing through the circuit. If you can remember, our DC power supply is set to supply a maximum of 50 milliampere. And in fact, our circuit will draw much less than that. So when measuring the current, I can just use the milliampere function here. And of course, the red test leads will be connected to the milliampere terminal. If you set the multimeter to the ampere function, you connect this red test lead to the red positive 10 ampere terminal. But in our case, for now, the milliampere function will be more than sufficient. It can handle 600 milliampere. The current we are expecting is much less than that. Now, in measuring the current, if you can remember our circuit here, it used to be this wire connect this side of the first resistor to the side of the second resistor. So when I remove this wire, there is no closed loop because this one is not connected to this one. Even if I switch on the power supply, current will not flow through the circuit because it's an open circuit here. And the reason why I remove this shorting wire or the jumper is because when you are measuring the current, you have to insert the multimeter set to a milliampere or ampere function in series with the circuit. Unlike when we are measuring the voltage, you can just connect it in parallel to the component. But when you are measuring the current, you basically have to insert the multimeter through the probes in series with the circuit. And we do that by basically removing this jumper. And in place of that, I connect the probes of the multimeter. Now, let us switch on the power supply, enable it. And you can see it is 7.02 7.06 or 7.07 milliampere, which is indeed much less than 600 milliampere. So that is how you use a handheld multimeter. So just again, just to illustrate, just emphasize the concept of the current flowing in the circuit. I will start again. Now it is on. Amount of around 7 milliampere is flowing out of this DC power supply through this red probe, through this red interconnecting wire, there, through this resistor, and then through the red test lead of the multimeter. There, go to that milliampere terminal, go inside the multimeter where its measuring circuit will measure the current, and then out here to the black test leads of the multimeter, going to that end, flow through the resistor to that black wire, to that black terminal, again to this black test probe, back to the black or negative terminal of the power supply. So that is the conventional current flow flowing through the circuit. Well, you might say, I mean, when measuring the current through the circuit, does these two terminals, I mean, this from this red test probe to the black test probe, would it be introducing additional resistance in the circuit? And the answer is yes. In practical circuits, there is always a small amount of resistance. I mean, when or in other words, when the multimeter is set to the current function, it has a small amount of resistance being introduced into the circuit. So in other words, you can imagine that there is a small resistor here due to our multimeter, but that is negligible. It's better these days. But still, the fundamental principle is that an ammeter or a multimeter set to a current function will introduce some sort of resistance, a very small resistance, which in most cases is negligible. Unless the values of the resistors are so small that introducing this small resistance will basically alter the characteristic of the circuit. But for us, we have 1K, we have around 286 upon ohms. This series resistance due to the multimeter is very small. It's probably even less than 1 ohm. So practically it will not affect our circuit. And although I forgot to mention, when you're measuring the voltage, the multimeter will also introduce some resistance, but an ideal, a practical multimeter has around 10 meg of an ohm. 10 meg in parallel with a 200 or 1K will not really change the characteristic of the circuit. So what I'm trying to emphasize here now is that when you are trying to measure the current, you have to put it in series with the circuit, like what we have done. We remove the jumper here, and instead of the jumper, we use, basically, it's the multimeter, which is now connected between these and these. And it has a small resistance, which for most practical situations is negligible. And what is the value of that series resistance? I mean, we can look at the specs of this multimeter later and probably explain it more. But now we have covered at least how to measure the resistance, how to measure the voltage, and now how to measure the current. Now, of course, like what we have done in the voltmeter or multimeter configured to voltage, we can, of course, switch the probe. But before I do that, let me just switch off the power supply. Disable it. And now we will connect the red probe here and in here, and let's see what will happen. Let's enable it again. And look, I mean, again, it's the same with the voltage. You get the same numerical value, but now it is negative 7 milliampere. So what we are saying is, we know that the current is flowing in this direction, so this is more positive with respect to that, or in other words, this is more negative with respect to that. But because we intentionally connect the red probe here, so that's why we are getting a negative. So as a summary, when we are trying to measure the current in the circuit, we connect the multimeter in series with the circuit. And that is the case here. And when you're trying to measure the voltage, you connect the multimeter in parallel with the component. I guess we can end here, and I'll see you in the next video.